Hello everyone, today we are not solving lead code. Today we are going to understand what is two pointers. This is one of the most asked DSA patterns in the interviews and people still have many confusion between two pointers and sliding window and when to use two pointers, why to use two pointers, how does this actually make n square complexity into order of n, how does all this happen, and we are going to understand everything in depth. This video is going to be the last video you will need to see on two pointers. Now before we go ahead, I am assuming you have basic understanding of programming. You know how loops work, you know what is big O of n square, you know all this basic stuff. I'm assuming you understand them and then only you are able to come to this point to learn two pointers. So now let us understand two pointer approach. So what is two pointer approach? So two pointers is actually a technique in DSA that helps us to solve particular type of problems that involve pairs of elements, not range of elements. Do you understand? We are going for pairs of elements. That is important. This range of element is not our concern. So what this simply means is that in any question in DSA, if you have to deal with A comma B, this kind of pair, then you can actually go ahead and use two pointer technique. It's a very strong indication that you are supposed to use two pointer technique. So anywhere you see that you have to deal with two elements and you have to find their sum, you have to find their subtraction, you have to find their multiplication, you have to find their division, you have some kind of condition that you are supposed to check for it. The question has given you some kind of condition that you are going to check for this particular pair, then there is a high chance that you are supposed to use two pointers. Now understand the meaning of this thing. We are not dealing with ranges here. What this means is that we will have some kind of linear data structure. Maybe we have an array, we have a string, and we are only considered or we are only concerned with the pairs of elements. So I have 1 comma 3, that is a pair. I'm checking the condition, or I'm getting the sum, or I'm getting the division, or I'm doing something with the pair. What it means is that the conditions of the questions will apply to the pairs in isolation. It means any element or a range of elements between the pairs does not matter for checking the condition on this pair. This is going to be in isolation. But if the question says that this element is also going to be somewhat responsible for you to check the condition, then that will actually become a sliding window. Sliding window deals with a range of elements, not just pair. But two pointers, yes, two pointers only deal with pairs. Now sliding window is actually an extension of two pointers. Sliding window is like a child of two pointers, but that sliding window is used in different use cases. So this is like a very important difference that you need to understand between sliding window and two pointer approach. Now the next question is, where do you really use it? Of course, I mean, it's a technique, right? It is supposed to be used in some kind of situation, not every time. So you can use a two pointer technique whenever you see linear data structures. That's a very big indication that you are supposed to use two pointers. So if you see linear data structures like arrays, linked lists, or strings, it's a very good indication that you can actually go ahead and use two pointers. And it is because you can easily create and go through the pairs of elements, because it is easy to get access to elements. For example, if you have something like graph, one node here, one node here, one node here, then one node here, then one node here, it actually becomes very hard to get access of like this element and this element in constant time and then just make their pair and then do something with that. It's very hard, and usually it is not possible to optimize it using two pointers. That's why it is usually used in linear data structures like arrays, linked lists, and strings. Now understand that you are supposed to go through the entire question and know what the question is telling you. So if your question is saying that you have to deal with pairs, right? If your question is saying that there is a linked list or an array or some kind of linear data structure, then on the basis of both these things, you can make a guess that, okay, you are supposed to use two pointers here. Nothing works in isolation. Two pointers does not work in isolation. Two pointer is a technique that actually relies on the conditions given in question. So it is important that you understand what the question is saying. And based on the conditions given in the question, you judge whether you want to use two pointers or not. The next question is, why do we really use two pointers? What is the need? What is the reason that actually drives us to use two pointers? What is the kind of problem that we are trying to solve by using this particular technique, two pointers? So there are two reasons why you would want to use two pointer approach. Suppose if you have a brute force solution of order of n square and you want to optimize it to order of n, then you can try to use two pointer. Otherwise, if you have an order of n solution and you are currently doing the solution in two passes, that means first you are running a for loop and you are doing something with the data, right? And after that, you are again running a for loop outside of this for loop, and then you are doing something again with the data, and then basically you are getting the solution. You can eliminate need of one for loop and do everything within this for loop. That is basically doing it in one pass. So if you want to remove this two pass solution and turn it into a one pass solution, you can use two pointers. Now I'm going to elaborate on both of these points in detail with the help of examples. How are we even able to reduce order of n square into order of n, right? Because this is not going to work for every order of n square solution. If you have something like graph and you are getting like order of n square, two pointers is not going to work. So in what kind of situation are we able to convert this n square solution into an order of n? And in what kind of situation are we able to convert this two path solution into a single path solution? We are going to understand that with the help of an example. But understand guys that these 2 points do not work in isolation. If you do not have pairs in your question, if you do not have linear data structures like array or strings or like linked list, right, then these 2 points does not matter, right? Because you don't have the prerequisite to actually use two pointers. So all these points that we discussed till now, you need to combine all of them and then make a judgment that whether you can use two pointers or not in this situation. Nothing is working in isolation. Everything builds on top of everything else. And the next point is types. What are the different types of two pointer approaches? Understand guys that two pointers is just two pointers. We will simply have P1, P2, right? And they can be anywhere in the data structure. They can move in any direction. They can work however we want them to work based on the conditions of the situation. So these charts is basically a way for us to kind of segregate the different ways we can move the pointers. Otherwise, everything involving two pointers is simply two pointers. There is no point in having types. So that's why the type that we are going to discuss right now is something that we created for our convenience so that we will remember in what kind of situation or how we can actually use two pointers. So we have two types, the converging or diverging pointers, and we have another type that is parallel pointers. Now we are going to understand these techniques with the help of examples. Okay, so don't worry if you don't understand them right now. So in converging two pointer technique, we will have P1 and P2 at different places in the array, and we will be moving these pointers towards each other based on the conditions that have been provided in the question. In terms of diverging, we will have the two pointers somewhere in the array and we will move them away from each other based on the conditions provided in the question. Conditions provided in the question. So conditions will determine how the pointers are going to move. In the same way, we have parallel pointers. So we will have pointer P1 and we have pointer P2. They will be moving in the same direction, in the parallel direction, either in this direction or they can also move in this direction, but they will be moving in the same direction. So they will have a parallel direction to move. Now this may not make sense right now because it is very abstract because we are not dealing with any examples here. But in the examples, I promise you, you are going to understand each and everything about it. Now before we move on to the examples, there is one thing I would like to discuss and that is how. How are we able to actually take an order of n square time complexity and convert it into an order of n? How is it even possible for two pointers? And yes, you guessed it right. It is possible in a certain kind of situation. So it's a very specific situation where you can actually do this. You cannot do this in every kind of situation. So based on the discussion we had till now, we know that two pointers is used when we are dealing with pairs of elements, right? So suppose that I have an array like 1, 3, 5, 7. So there will be some pairs of these elements, right? How many pairs will there be? Well, we have 1 and we can make a pair with each of these elements. We have 3 and then we can make a pair with each of these elements. We have 7, we can make a pair with this, right? So how many pairs can we make? All in all, we can make n square pairs. We will have pairs like 1, 1, then 1, 3, then 1, 5, right? We are actually having pairs 1, 7, then we have 3, 3, 3, 5. And so a simple array of 4 elements actually end up creating these many pairs, right? These are so many pairs for 4 elements. And this is where we actually make the optimization. So in these kind of questions, you will be going through each and every pair and you will be checking for something or some condition in those pairs. And because we are going through all of these pairs, we end up running the loop for n square times. Hence, we actually get the n square time complexity. But what happens is that when we use two pointers, we actually use or we actually leverage the conditions given in the question to actually skip some of these, actually many of these pairs. So a huge subset of these pairs will be skipped. And that's why this entire order of n square will be converting to order of n. Now, which pairs will be skipped and how they will be skipped depends on the conditions of the question. And one thing is that you are not actually doing it consciously. It is going to happen automatically. The skipping is going to happen automatically if you understand the conditions of the question. We are going to understand or we are going to take an example to see how this really happens in action. So right now it's a very abstract explanation that okay, we have a few pairs and we just somehow skip a lot of pairs which make this n square into n. But now we are going to understand how it happens in action with the help of examples. Suppose we have a sorted array of height of people and we are supposed to give the pair of people whose sum of height is actually a given number x. So the x will be input. The x can be 4, 5 or anything else, this will be given as input. And here you can see that we actually have a linear data structure, right? We have height of people, right? And we have this condition in the given question. We have a sorted array. Okay, it's really important. If you ever see a sorted array or sorted data structure, it's very likely that you are going to use two pointers. But make sure that you are taking all the points into account that we have discussed till now, that is having pairs, right? So here you can see that we are explicitly saying that we need to find the pair of people whose sum of height is actually x. So we have linear data structure, right? We have pairs. We have a condition like sorted array. So we can be sure that, okay, we are going to use two pointers. So now how are we going to use two pointers? Well, let's take an example. Suppose we have an array like 1, 3. So we have this array, and now we want to find out the pair of elements whose sum will be, like, just say x equals to 9. So we want to find the pair of people whose height sum will be 9. So what we can do is we can try to use two pointer here. So which one are we going to use? Converging or diverging, or we are going to use parallel? That's the question. We can try both right now. If I have parallel, then I will have a P1 here. Then suppose I have P2 here. And now I actually check the condition. We have 1 and we have 3. What is the sum of 1 plus 3? Well, it is 4. So it is not 9, correct? It's not 9. Now we know that this 4 is less than 9. And so this is the point where you will use the given sorted array condition to decide which pointer is going to move. So here, since it is less than 9, we know that we need to get a bigger number. And in order to get a bigger number, we need to shift the pointer towards this direction because it's a sorted array. So this element is going to be bigger than this element. So we shift the P2 here. And now we have 7 plus 1. So we will have 7 plus 1 equals to 8, right? So we have 8, which is still less than 9. But one thing you need to notice is that what about 3 plus 7? When are we going to increment the P1? That's not clear, right? Yes, I mean, it's sorted array, but it is still not clear when or how are we going to use or how are we going to increment P1 to get this 3, 7 pair. How are we going to do that? How are we going to check that? And here you can see that, okay, parallel might not actually work. So we may try to use converging. So once again, we will have pointer P1 here and we will have pointer P2 here. Now we will try to actually get the pair. Right now the pair will be 1 and 12. What is the sum of 1 plus 12? It is 13, right? Which is greater than 9. Since it is greater than 9, we are going to use the given condition of sorted to actually decide which pointer is going to move. Since it is greater than 9, we need to get a lesser number, right? So how are we going to get a lesser number? Well, we need to reduce the biggest number in our pair. In the pair, we have the biggest number 12. It means we are supposed to reduce P2. So P2 will be here and we have 11. Now 1 plus 11, still 12, right? It is still greater than 9. We will again shift the P1 and 1 plus 10, well, 11. We will again shift it and we will be here now. 1 plus 9 is 10. We will again have to shift it, right? So we will shift it to the 7. Now P1 is still at 1, right? So 1 plus 7 is equals to 8. It is less than 9. So 8 is less than 9. It means we should now get a bigger number. To get a bigger number, we need to increase the minimum number in our pair. So the minimum number is what? 1. We need to get a bigger number than 1, right? So we will shift the P1 to this place. So now we have 3. 3 plus 7, it is 10. Now it is greater than 9. So we will reduce P2. So P2 will be reduced and P2 will be here. So P2 and P1 are at the same position and we have not found this particular X. It means we can actually stop the loop and we know that there are no two pairs in the given array that actually sum to the 9. So this is an example where we don't get any pair that is actually going to give us the sum of 9. Now here's one thing you need to notice. When we were shifting P2 from 12 to 11, what do you think we were doing? Well, we were actually skipping the pair like 3, 12, right? Because once we shift the pointer to 11, we will never ever be able to calculate this or get to this pair, right? 3 is here. So we can, yes, shift the pointer to 3 and we will get the 3. But in order to get the 12, the P2 needs to be at this position, right? But we shifted the P2 to 11. So it means we essentially end up skipping this particular pair. Similarly, when we shifted the P2 here on 10, so what we did is we ended up skipping 3, 11 also, right? In the same way, we ended up skipping a ton of pairs. I'm just giving you a few examples, but we skipped 3, 12. We skipped 7, 12, right? We skipped 9, 12. We skipped 10, 12. And this happened by the given condition, that is the sorted array condition. So we did not actually skip these pairs deliberately. They just got skipped automatically because we used the given condition to actually decide how we are going to move the pointers. And while moving the pointers, we just automatically end up skipping many of the pairs that would not have been able to give us the proper answer. Now, of course, if we were actually had x equal to 8, then eventually when the P2 was here, we would just get 1 and get 7, and that will actually be like 1 plus 7 equals to 8, and we will simply return this 1 comma 7 or P1 comma P2, and that will be answer. But even in that case, we would be actually skipping many of the pairs, just like this. If we did not use two pointers here, what do you think we will be doing? We will take each and every element and we will create a pair with each and every element in the array, and that will give us around n square pairs, and then we will go through each of those pairs just to see if the sum is actually 9 or not, and that would have caused order of n square time complexity. But here in the pointer approach, we just went through each and every element only once, which actually reduced the time complexity to order of n. Why? Because we actually skipped a ton of pairs, and we only dealt with the pairs that have some potential or that could have been the part of the answers. And we were able to do this just because of the given condition in the question. So the conditions in the question will determine how the pointers will move. Make sure that you understand the conditions in the question. Now here is another example. Find if a given string is a palindrome or not. So this word palindrome actually consists of many conditions. What is a palindrome? So basically we will have a string like race car, or we will have a string like noon, and we have to tell whether these two strings are palindrome or not. So to solve this question, we will need to understand what is a palindrome. Palindrome is simply any string that if you read it from left to right, it will be same as reading from right to left, which basically means if you take a string like race car, you reverse it and you actually compare it with the original string, they will be same. So I have the race car string here. I will now reverse it. So I will take R here. Okay, R will be here. Then A will come here. Then C will come here, right? Then E will come here, race. Then again C will be here. Then A will be here, and then R will again come to here, right? So you see this string race car, and this one is also what? Race car. They are basically the same string. Similarly for noon, if I take N here, then O will be here, then O will come here, and then N will come here. I have reversed the string and it is still the same string. That is what a palindrome is. Now how will you use two pointers? Well, understand the brute force solution. What you will do in the brute force is you will take the string, you will reverse it, and then you will what? You will compare it, right? You will compare this word with this word, right? So P1 will be here and P2 suppose will be here. So you are comparing whether this is equal to this or not. If they are equal, P1 will be incrementing, P2 will be incremented. A will be compared, right? Then C will be compared with each other. Then E will be compared, right? In the same way, you are taking pairs of two things and you are comparing them, correct or not? Yes, you are comparing them, which is amazing. So now you need to observe something. This particular R, what is it that you are comparing it with? You are comparing it with this R alphabet, right? And this R alphabet is actually coming from where? It is coming from the end of the original string. So what you are really doing is that you have a string like race car and you are actually comparing the end elements. Okay, so this element is compared with this element is compared with this element, this C is compared with the ending C, right? This E will be compared by itself. So that's how you are basically comparing. So what if instead of creating another array and actually taking order of n space complexity, what if I just use pointers? So we again have the same string. We will have pointers P1 here. We will have pointers P2 here. We will compare the element at P1 and P2. So P1 element is R, P2 element is R. They are same, right? So based on the properties of this palindrome, which actually turns out to be conditions of the question, we know that we need to shift the P1 to next because we want to compare the next element because these elements are just fine, right? We don't have to worry about them. So we shift the P1 to the A and we shift the P2 to this A. Then we compare, is this equal to this? They are the same, correct? So we again shift the P1 to C and P2 is shifted again to this element. So P2 have C. Is this equal to this? Well, yes, it is equal. Then again, we shift the P1 to E and we shift the P2 to E again. Now we check, is the element at P1 and P2 equal? Well, it is the same element, so yes, it is equal. So we can see that, okay, given string is palindrome, so we will simply return true. And here you can see that by using two pointer approach, what we did is very simple. We did not reduce the time complexity from order of n square to order of n. That did not happen. The original time complexity, the OG time complexity was also order of n, right? All you were doing is that you were just reversing the string and then comparing it. So you reverse the string and then you compare it. These were the two steps that we were following in the original solution, the brute force solution. So reversing will take what? Order of n, and comparing will take what? Order of n time complexity, right? So we did not really improve the time complexity because the time complexity in two pointer is also order of n. So what did we really optimize? We removed one of these steps. We removed the step for reversing, right? The reason we had to reverse it is because we wanted to compare this one with this element, right? So we removed this particular steps. This got removed, which means earlier we had to run the loop two times. We had to run the loop two times. Now we only have to run the loop for comparing. That is the only thing we are doing. We are taking these elements, right? And then we are comparing, and that is the only thing we are doing in the loop. So that means the solution that was two pass, it got converted into this one pass solution. And this was actually the second reason to use two pointers. The first one was to get the time complexity from n square to n. The second was to actually convert the solution from two pass into one pass. So what this means is that in a two pass or three pass solution, you will have a few steps. You will be doing something in all those steps. You will need to understand based on the given condition what is the step that you can actually skip. What is the step that is a redundant step? And here the reversing of the string was actually redundant. It was not necessary. So we removed that and we just focused on the comparing part. And by doing so, we also saved space. So in the original, the space complexity was actually order of n because we were creating a new string. We were reversing it, and that reversed string was actually a new string taking up as much space as the original input. But right now we are not reversing the string, so the space complexity for us, the two pointer, is order of 1, that is constant. Isn't that crazy? So here we have another question. Suppose we have an array that contains numbers and zeros. Okay, we have to place all the zeros at the end of the array. So, okay, first of all, we have a linear data structure. Great. Now we don't have pairs here. So nothing in the question actually talks about pairs, and we just have numbers and zeros. So first of all, we should try to actually get a brute force approach, right? So the input will look something like this, right? We will have 1, 0, 7, 0, 0, 8, 9, right? Something like this. And we have to place all these zeros to the end. So what we can do is that we can create a list. This is going to be a list. And we can actually go through this array. We will have a loop on this original array, and we will check if the current element, that is the ith element, is actually a number or a zero. So currently it is a number. I will take 1 and put it into the new list. Then I will go here. It's a 0. I will not put it. Then I will be here, right? It's a 7. I will put it here. Then I will be here. 0, not going to put it. 0, not going to put it. Then I will be here. 8, right? So 8, I will place it in the new list. Then I will be here in the loop. 9, I will place it in the new list. So I have a list of what? I have a list of numbers, right? And now what I can do is very simple. I can simply go ahead and actually make modifications in the original list, or I can create a new list. But let us try to make modification in the original list to save some space. So what I will do is very simple. We have original list 1, 0, 7, 0, 0, 8 and 9, right? All I need to do is get all the zeros at the last. So what I can do is I can take this one and override it here. So 1 will directly go here and nothing happens because it was already 1. But if I take 7 and try to override this position, I will have 7. Now I can take 8 and override this particular position. So we will have 8 here. Now I take 9 and override this particular position. We have 9 here. Now what I can do is that I can override everything else or every position else with a 0. So it means we took all the zeros, placed them at the end, right? That basically solves the problem. This is a brute force way of doing it. So now let us try to see what we are doing here. First of all, we are creating a list. The reason we are creating a list is to get access to the numbers, right? Make sure that we have access to the numbers all the time. And then we are just overriding the original list. So what we have here, we have step 1 and we have step 2, right? So if we can actually somehow remove one of these steps, we will have what? A single pass solution, right? And we can use two pointers to actually get this one pass solution. So this actually gives us a hint that we can actually use two pointers to solve this particular question. Now, if you really look at it, what is happening here? Well, we had 1 here, right? And we placed it here. It is same. But we had a 0 at this position and we placed a 7 at that position. What happened is that this 7 shifted. Basically, in a sense, that's what happened, right? This 7 came to this particular position, right? And since it came to this particular position, we actually had a 7 in this place, right? We had a 7. But this 7 was what? It's a copy, it's a duplicate. So we could override this 7 safely with some other number. So what we did is we simply took this particular number and we override this position with this number, right? Then again, we had 8 here and we again have an 8 here. And then what we did is we took this 9, right, and we override this particular 0 with 9. And once we are done with this 9, the ending number, what we did is we simply took all these numbers that were at the end and we just made them 0. We override them with 0. That's pretty much what we did. So how we can do this with the help of two pointers? So we again have the same array, the same input, and we will have P1 and P2 at the starting. Both of them are pointing to 1. Now what we can do is we can check if the current element is a 0 or not. Since it is not a 0, we will take one of these pointers and we will shift them to next one. So we will have P2 shifted here. So P1 is at 1, P2 is at 0, right? So it means we have found a 0. And now that we have found the 0, what we can do is we can simply shift the P2 again. So we did not do anything when P2 was at 0, right? But now that P2 is at 7, we found a number, right? Now we want to take this number and put it at the start so that all the zeros will be at the end. So what I know is that P1 will be at a number, at a particular number, and the next position is going to be 0. So what I will do is that I will take the 7 and I will replace or swap it with this thing. So here's what I will do. The element at P1 plus 1 will be swapped by element at P2. Remember, we are not swapping P1, we are swapping P1 plus 1, the next index from P1. Now when the swapping happens, we will have 7 here and then we will have what? 0 here, correct? And then we will shift the P1 to this place. So P1 is at this place right now. So we have removed this 0 from here and we have shifted it to this place. The 7 has also been removed from this place and it is now here. So now the P2 is pointing to 0. We will do nothing. We will just shift next, right? P2 is again pointing to 0. We will do nothing. Shift. P2 is pointing to 0. We will do nothing. Then shift. P2 is now pointing to a number. Now we have a number and we can actually swap it again. We need to put it at the start so that we will have all the zeros at the end. So we will take this 8 and we will swap it with the P1 plus 1 index. That is P1 plus 1 is what? This one. This is the element at P1 plus 1 index. So again we will swap. So after swapping, what do you think will happen? After swapping, this 0 will be gone and we will have 8 here, and this 8 will be gone, we will have a 0 here. So now P2 again points to a 0 and the P1 will be actually shifted to this place. So P1 is now pointing to 8. And then since it is 0 right now, we will simply shift P2 again to this place. It is 9. We have again a number 9. We will take this number 9 and we will swap it with the P1 plus 1 index. That is this one. So we will take this 0 and we will take this 9. We will swap them. So 9 is here and 0 is here. And then the P1 will be shifted to this place, right? And the P2 will be shifted next place. So P2 after this 9, well, it is going to go out of bounds. So we can simply stop the loop. So at this point, we have what? We have 1, we have 7, we have 8, we have 9, and then we have 0, 0, and 0. So all the zeros have been shifted towards the end of the array. So now do you understand how we are using the two pointers? So we knew that P1 will always be at a number, right? And the next element of P1 is going to be 0. That's why we had a pointer P2 that was going ahead of P1, exploring all the next elements. And as soon as it finds a number, it was used to swap this 0 from the element at P2, the number at P2. And then we would also increase the P1 so that the P1 will always be at a number and the next to the P1 will be a 0. So that's how we were able to solve this particular question. So the question that was actually a 2-pass in the original solution is now a 1-pass or a single pass solution. This is where we are actually using the two pointers. So I hope you understand how the two pointers is used. And now I would like to show you one more example, that is merge to sorted array. So here we will have arrays like 1, 3, 7, 9 or 8 maybe, and 10. And then we have another array that is 2, 5, 6, 9, 12. So we will have two sorted arrays. Both of them are sorted in ascending order, right? And we have to merge these sorted arrays into a single array. So how we can do that? So the brute force way is to just combine these two arrays into a single array, and then we will simply apply the sort function on those arrays. And that will cause what? That will have order of n log n time complexity, which is too much for this kind of problem. We can actually do better. We can do it in order of n. So we will again have to create a new array, of course, but now we will have pointers. P1 will be here and P2 will be here. And now we will check which of these elements is smaller. So 1 is smaller. So we will take P1 element and we will place it here. And then we will shift the P1 to the next element. So P1 is now at 3. We will take which one is smaller, 3 or 2? 2 is smaller, so we will take 2 here and we will shift the P2 to the next element. Now we will check which one is smaller, 5 or 3? 3 is smaller, so we will take 3 and shift the P1 to the next element, that is 7. Which one is smaller, 7 or 5? 5, right? So we will take 5 here and then shift the P2 to the next element, that is 6. So P2 is at 6. Now which one is smaller, 7 or 6? Well, clearly 6. So we will take 6 here and we will actually shift the P2 to the next element, that is 9. Which one is smaller, 7 or 9? 7, right? So we will take the 7, we will shift the P1 to 8. Now which one is smaller, 8 or 9? 8. So we will take the 8 and we will shift the P1 to the next element, that is 10. Which one is smaller now, 9 or 10? Well, 9. So we will take 9 and we will shift P2 to the next element, that is 12. Which one is smaller now, 10 or 12? It is clearly 10. So we will take 10 and we will shift the P1 to the next element. It is out of bound. We will stop the loop and we will take all the remaining element in the other array. We will place them in the final array. So here you can see that we were able to merge the two arrays into a new sorted array with the help of two-pointer approach. And the time complexity here is order of n. N is basically the length of this array and the length of this array combined, because we have two pointers going through each and every element of the two arrays. So that's why n is basically the combined length of both the arrays. Now I wanted to show you this example because I wanted you to understand that two pointers simply means two pointers. Okay, they do not have to be in the same array. They can be in different arrays, because here what we are doing is that we have two elements, okay, 1 and 2, which actually creates a pair, 1 comma 2, and then we are actually comparing, or we are actually putting some kind of condition, we are checking them against a condition, and then we are actually placing the result of that condition here. So we have pairs, we are checking a condition on those pairs, then we are putting the result here. We have linear data structure here, correct? It's a linear data structure. It is basically a recipe for two pointers, right? Do you understand it? It's a recipe for two pointers, and this is what you have to notice in question. You have to see the question, you have to notice what are the elements that I have to deal with. Do I have to deal with the pairs, or do I have to deal with the ranges of elements? If I have to deal with the ranges of elements, you will be using sliding window, not two pointer. So make sure that you understand all the points that we have discussed till now. Everything we discussed till now, the order of n square, time complexity to n time complexity, two pass to single pass solutions, the linear data structure. So you need to understand that in order to find out whether you can use two pointer or not in a given particular question, you really need to observe different things. Like, have you been given a linear data structure, right? That's one point, or that's one indication. Are you dealing with the pairs of elements? Well, that is another indication. Are you having one pass or two pass solution? That is another indication, right? So if you have many of these indications, then you will be able to say, okay, I can go ahead and use two pointers in this particular question. And yes, guys, there is no guarantee anywhere. Like, these kind of techniques are very, very, very common. There can be many different ways to use them, but I have talked about the most common ways to use them. Like, the most lead code questions are like these questions. You will be able to understand whether to use two pointers or not. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet on the next video. Till then, bye.